Imagine a distant world, 120 light-years away, where clouds of water vapor drift through an alien atmosphere. Now, imagine that this same world may harbor life. Sounds like science fiction? Well, the James Webb Space Telescope, JWST, has recently detected intriguing signs of life on exoplanet K2-18B, and scientists are buzzing with excitement. But there's a catch, a problem that complicates the discovery. What's really happening out there? Stick around to unravel the mystery with us. Who would have thought that just 120 light-years away, we might find the first hints of alien life? Once again, the incredible James Webb Space Telescope has delivered a groundbreaking discovery. This marvel of technology has turned its powerful gaze toward a distant planet and unveiled signs of what could be extraterrestrial life. The exoplanet K2-18B is making waves in the scientific community. Initial analyses suggest it's a rich water world, potentially hosting far more life-sustaining conditions than Earth itself. Orbiting a red dwarf star, K2-18B sits just over 120 light-years from us and has already cemented its place in astronomy's history books. What makes K2-18B truly exceptional are the potential signs of biological activity detected in its environment. Using its cutting-edge spectrometer, the James Webb Telescope identified 4 key signatures associated with life. This discovery is nothing short of extraordinary and has ignited hopes of finally confirming life beyond Earth. The findings offer a tantalizing glimpse into the possibility of a living universe. Thanks to the unparalleled precision of the James Webb Space Telescope, we may be closer than ever to answering one of humanity's greatest questions. Are we alone? Scientists quickly realized that this exoplanet holds a unique place among the worlds we've discovered. Early analyses revealed significant amounts of water, setting off alarm bells among researchers. What followed could reshape science as we know it. For the first time, we're studying a planet that might answer profound questions. What is life? How does it emerge? Even more exciting, this discovery could reveal that life in the universe is far more diverse than we ever imagined. The possibility of countless life forms, each unique in its nature, has captured the curiosity of not just scientists, but people around the globe. The exoplanet K2-18B is now at the forefront of this groundbreaking exploration. Scientists identified 4 key biomarkers, pointing to a world rich in water and, for the first time, providing compelling evidence of extraterrestrial life. Among the discoveries were traces of methane and carbon dioxide, 2 gases that, when found together, strongly indicate biological processes. This extraordinary find could finally bring us closer to answering humanity's age-old question: are we alone in the universe? Imagine hitting the jackpot in the search for extraterrestrial life. K2-18B just might be it. Scientists have uncovered not only methane, carbon dioxide, and water on this distant planet, but also something even more extraordinary: dimethyl sulfide, DMS. This gas, often overlooked on Earth, is being hailed as a game-changer in the search for life beyond our world. DMS is produced by algae during their metabolic processes and is commonly found near seas, oceans, and wetlands on Earth. Its presence on K2-18B suggests something astonishing: life may exist in the planet's oceans. This discovery is more than just a clue, it's a scientific sensation. For the first time, a spectrometer analysis has revealed such clear signs of biological activity on another world. Algae, some of the simplest life forms on Earth, are thought to have populated our planet's ancient oceans long before more complex creatures like fish and mollusks appeared. They were likely key players in shaping the evolution of life as we know it. If algae or similar organisms exist on K2-18B, they could hold the key to understanding how life emerges and evolves across the universe. The detection of DMS on K2-18B is nothing short of revolutionary, suggesting that we may be closer than ever to unraveling the mysteries of life beyond Earth. Could the humble algae be the common denominator linking life across the cosmos? The possibilities are endless, and the journey has only just begun. K2-18B might just be the proof we've been waiting for, evidence that at least algae could exist in its vast oceans. And where there's algae, there's the potential for even more complex life. While this discovery is groundbreaking, scientists are approaching it with cautious optimism. For now, they're holding back from declaring the discovery of alien life, even though all signs seem to point in that direction. The combination of dimethyl sulfide, DMS methane, carbon dioxide, and abundant water are strong indicators that K2-18b could be the first truly habitable planet we've identified in the universe. Let's focus on methane for a moment. On Earth, methane is tightly linked to biological processes, and its presence on K2-18b dramatically boosts the likelihood of life there. James Webb's advanced spectrometer revealed a unique blend of methane and carbon dioxide in K2-18b's atmosphere, signaling the possibility of a biologically active world. For comparison, Saturn's moon Titan also has large amounts of methane, but it lacks critical biomarkers like water or oxygen, making it unlikely to harbor anything beyond basic methane-based bacteria. This discovery leads to one of the most profound questions. If oceans with warm water and algae exist, could they eventually produce higher forms of life? K2-18b may be the key to answering this mystery, taking us one step closer to understanding life's potential across the cosmos. The search for the secrets of life's evolution is one of the greatest quests in science, and K2-18b may hold the answers. The thrilling discovery of biosignatures in this distant planet's atmosphere could be a major step toward understanding how life emerges across the universe and how it developed here on Earth. Methane, a key ingredient in this discovery, is primarily produced by microorganisms, but it also comes from other sources like the digestive systems of ruminants and large rice paddies. While methanogenic microorganisms don't live in methane, they produce it as part of their metabolic processes. On K2-18b, the presence of methane, along with dimethyl sulfide, DMS, strongly suggests one thing: an abundance of plant life. On Earth, algae and certain phytoplankton species produce large amounts of DMS, which then enters the atmosphere. This process is similar to what we've observed on K2-18b, where DMS is likely being generated through biological activity, possibly from plant life in the oceans. But what does K2-18b's surface actually look like? While we can analyze its atmosphere in remarkable detail, we're still not able to get a clear picture of the planet's surface. The James Webb Space Telescope is a powerful tool, but even it can't give us the full view yet. However, what we can learn is transforming our understanding of what life might look like beyond Earth. The James Webb Space Telescope uses its advanced spectrometers to analyze the light that distant planets absorb from their stars and then re-emit. This process creates a distinct pattern of light across different wavelengths, allowing scientists to detect subtle differences. For example, water and oceans reflect light in a unique way compared to forests, mountains, or deserts. By studying this light, the Webb telescope can identify gases in a planet's atmosphere, revealing potential biomarkers like methane and DMS. In the case of K2-18b, our technology allows us to capture the light imprint of the planet. While we can't get a direct image of its surface, we can analyze the vapor in its atmosphere, including the metabolic byproducts of algae or single-celled organisms. We might even be able to detect the carbon dioxide exhaled by life forms living on this world. However, we can't yet see the life forms themselves, so their exact appearance remains a mystery. What we do know from the James Webb Space Telescope's data is that K2-18b is a massive water world about 8.6 times the size of Earth and is surrounded by a thick, hydrogen-rich atmosphere. This planet belongs to a newly discovered class known as Hycean worlds. The discovery of Hycean worlds came as a surprise to scientists, who previously believed that water in such large quantities wouldn't exist on planets like this. But now, K2-18B is challenging what we thought we knew about the potential for habitable worlds beyond our own. When the first Hycean worlds were discovered, it was like a cosmic revelation, huge, water-covered planets seemingly appearing out of nowhere. These planets are even more submerged by water than Earth, and they're significantly larger than the rocky worlds we're familiar with. This makes them especially exciting, as the vast presence of water increases the chances that life could exist there. Hycean worlds tend to be a bit warmer than Earth, often resembling gigantic natural greenhouses. If the temperature is just right, not too hot, they could create the perfect conditions for life to thrive. Imagine a superworld entirely covered by oceans, teeming with vibrant, colorful life in its waters, much like the most stunning coral reefs on Earth. What's even more fascinating is that such a world might not only support simple life forms, but could potentially harbor more complex creatures. Could a civilization evolve on a water planet? Perhaps intelligent, hybrid beings made of both aquatic and advanced life forms could exist. K2-18B could very well be the first glimpse of abundant life beyond Earth, and it's sparking our imagination about the strange, colorful aliens and diverse life forms we've only seen in science fiction. As we continue to study K2-18B and other Hycean worlds, we may soon find that the alien civilizations we've dreamed of in movies and books could be closer to reality than we ever thought. Only time will tell. Scientists are currently developing new technology that will allow us to scan biomarkers and metabolic products on distant planets with even greater precision. This could help us determine whether any of these planets show similarities to life forms here on Earth. But in the meantime, astronomers are being kept on their toes by strange and mysterious phenomena, like the eerie glow surrounding the exoplanet JWST-76b. While JWST-76b may not be a top contender for hosting life, it continues to puzzle scientists with its bizarre glow. This hot Jupiter, located in the constellation Pisces, orbits so close to its star that its day side reaches an astonishing 2400 C, hot enough to vaporize iron. But it's not just the extreme temperatures that have caught researchers' attention. In recent years, they've observed an unusual glowing effect around the planet, and this glow could potentially hold the key to solving one of the greatest mysteries of the universe. This glow is similar to the glory effect we see here on Earth, which occurs when sunlight scatters off tiny water droplets or aerosols in misty mountains or dense cloud layers. Powerful winds then carry this iron mist across to the cooler night side, where it condenses back into liquid form. Incredibly, this means iron actually rains down on the planet. These evaporating and condensing metal clouds create the perfect conditions for a phenomenon known as the glory effect. Scientists believe that when the light from the nearby star hits these iron clouds, it's reflected and scattered, producing the ring-shaped glow that surrounds JWST-76b. But the real sensation of this glow goes beyond its beauty. It's a sign of the exotic physical processes happening on this strange world. These unusual processes are so perplexing that they challenge our understanding of physics itself. With the help of the James Webb Space Telescope, scientists are detecting increasingly bizarre effects on distant exoplanets. The strange phenomena observed on planets like JWST-76b are pushing the boundaries of what we thought we knew about the laws of nature, raising questions about the limits of our scientific understanding. K2-18b is no ordinary planet. Located in the constellation Leo, it orbits a red dwarf star within the habitable zone where conditions might allow liquid water to exist. This exoplanet is classified as a Hycean world, a type of planet larger than Earth but smaller than Neptune, with the potential to support oceans beneath its hydrogen-rich atmosphere. Its discovery in 2015 sparked interest, but recent observations by JWST have elevated it to a whole new level of significance. Why? Because K2-18b is now a top candidate in the search for alien life. The JWST, equipped with the most advanced infrared technology, recently captured detailed data from K2-18B's atmosphere. The telescope identified the presence of water vapor, an essential ingredient for life. More importantly, scientists detected hints of a molecule called dimethyl sulfide, DMS. On Earth, DMS is primarily produced by marine microorganisms, making its presence on K2-18B incredibly intriguing. Could this be the smoking gun for extraterrestrial life? Not so fast. The discovery is groundbreaking, but it raises more questions than it answers. While the presence of DMS is exciting, the challenge lies in the planet's dense hydrogen atmosphere. Hydrogen-rich atmospheres are vastly different from Earth's. They are often inhospitable, with extreme pressures and temperatures that could potentially crush or incinerate life as we know it. So, how could microorganisms survive or thrive under such conditions? Scientists believe that if life exists, it would have to be radically different from anything we've ever encountered. This problem underscores the complexity of interpreting these findings. Exciting as it sounds, the scientific community remains cautious. Detecting a molecule doesn't confirm its origin. DMS could theoretically be produced by non-biological processes, like chemical reactions in K2-18B's atmosphere or geological activity on its surface. Moreover, the data from JWST, while impressive, requires further analysis and confirmation. Misinterpretations have happened before, and no scientist wants to jump to conclusions. Rigorous scrutiny is essential before proclaiming the existence of life on another world. So, what happens now? The JWST will continue to observe K2-18B, collecting more data to refine our understanding of its atmospheric composition. Meanwhile, other advanced telescopes, like the Extremely Large Telescope, ELT, set to launch in the near future, could join the hunt. The ultimate goal? To distinguish between biological and non-biological sources of DMS. While it may take years to confirm or debunk the findings, one thing is clear: K2-18B is a fascinating stepping stone in humanity's search for life beyond Earth. The James Webb Space Telescope, JWST, has truly revolutionized our understanding of the cosmos. Equipped with an unprecedented ability to observe distant worlds in infrared wavelengths, JWST has given scientists a new lens through which to study exoplanets. Unlike earlier telescopes, it can peer through cosmic dust and gas clouds to reveal the true nature of planets like K2-18B. With its powerful spectrometers, JWST allows researchers to identify chemical signatures in planetary atmospheres, including the potential for life-sustaining molecules. This new capability has opened doors to understanding distant planets like never before. The habitable zone is a key concept when discussing the potential for life on other planets. It refers to the region around a star where conditions are just right, neither too hot nor too cold for liquid water to exist. K2-18B orbits within its star's habitable zone, making it a prime candidate for life. While water alone doesn't guarantee life, it's one of the essential ingredients. Scientists believe that planets like K2-18B could harbor life forms similar to Earth's microorganisms, provided the right conditions are met. Although K2-18B is located in the habitable zone, it's very different from Earth in many ways. Its size alone sets it apart. This exoplanet is about 2.5 times the size of Earth, placing it in a category that scientists refer to as a super-Earth or mini-Neptune. These planets are thought to have thick atmospheres, possibly composed of hydrogen and helium, making them quite different from Earth's oxygen-rich atmosphere. Despite this, K2-18B's location in the habitable zone means it might share some similarities with our own planet in terms of its potential to harbor life. Dimethyl sulfide, DMS, is a crucial part of this mystery. On Earth, it's primarily associated with marine microorganisms, such as plankton and algae. These organisms release DMS into the atmosphere as a byproduct of their metabolic processes. So, when scientists detected traces of DMS in K2-18B's atmosphere, they immediately considered the possibility that life, perhaps microbial, could exist there. However, the presence of DMS alone doesn't guarantee biological activity. It's just one piece of a much larger puzzle that researchers are still trying to solve. While DMS is often a biological marker, scientists can't rule out the possibility that it could form through non-biological processes. For example, chemical reactions involving sulfur compounds in K2-18B's atmosphere could produce DMS without any involvement of life. The challenge is determining whether the DMS on K2-18B is a result of biological or abiotic processes. This uncertainty is why scientists are taking a cautious approach in interpreting the data from the JWST. Welcome to Blessovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blessovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe, live Q, and sessions with experts. Your membership will grant you the chance to participate in live Q and sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blessovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comment.